Every major leap in human ingenuity eventually finds its way to the front lines. But what happens when the distance between a clean engineering lab like this one and the theatre of war completely vanishes? Right now, across the heavily contested skies of the Middle East, traditional military doctrines are being violently rewritten. What we are witnessing is no longer just regional escalation, it is a global paradigm shift. We have entered an era where modern combat is no longer defined by the courage of pilots in the cockpit, but by the clinical efficiency of the machines left entirely on their own, and the cost of this evolution is steeper than we are willing to admit. To understand the impact of this technology, we must look at how it changes battlefield visibility. At the core of modern drone deployment is a capability known as ISR, intelligence, surveillance, and reconnaissance. Traditionally, military commanders lacked real-time visibility over wide areas. Today, uncrewed platforms act as persistent sensors, significantly reducing what historians call the fog of war. Long-endurance drones can remain airborne for over 24 hours at a time. Equipped with high-definition optical, thermal, and radar sensors, they continuously stream geographical data and track assets. This information is instantly routed through satellite constellations to analytical teams worldwide. In modern strategic planning, information parity is no longer assumed. Persistent surveillance has become the baseline requirement for any operation. Beyond data collection, uncrewed platforms have fundamentally changed how kinetic strikes are conducted, particularly in dense urban environments. Traditionally, targeting an asset inside a city required heavy artillery or manned aircraft, which carry high operational costs and significant risks. Modern military-grade drones utilize precision-guided munitions to strike specific, pre-coordinated targets from kilometers above, reducing the physical footprint of the attacking force. However, contemporary conflicts show a shift toward a more decentralized method. The deployment of low-cost, commercial off-the-shelf drones. By integrating explosive payloads onto inexpensive consumer quadcopters, forces can deploy dozens of small units simultaneously into urban areas. These small platforms utilize the city's own infrastructure, flying low between buildings and streets to avoid detection by traditional radar systems. This combination of precision high-altitude platforms and mass low-cost swarms represents a highly complex challenge for modern urban air defense. The rapid evolution of drone technology has introduced a unique challenge to global security, the concept of dual-use proliferation. Unlike traditional military hardware, which requires highly specialized defense manufacturing pipelines, modern uncrewed aerial systems rely heavily on commercial off-the-shelf components. Standard microprocessors, global positioning modules, and lightweight carbon fiber frames manufactured for consumer hobbies are easily acquired through international commercial markets. When these low-cost components are weaponized, they effectively democratize air power. Smaller nations, insurgent groups, and non-state actors can bypass traditional, highly restrictive defense procurement channels. By assembling improvised drone fleets for a fraction of the cost of a single conventional combat aircraft, these groups can project asymmetric force, significantly lowering the financial and industrial barriers required to initiate conflict. This democratization of uncrewed technology has direct consequences for global stability, because small drones can be launched from decentralized, hidden positions and lack clear radar signatures. Identifying the precise point of origin is incredibly difficult. This plausible deniability weakens traditional military deterrence models, allowing state and non-state actors to conduct cross-border strikes with a reduced risk of immediate attribution or retaliation. The systemic impact is highly evident in global trade corridors. Low-cost autonomous systems have been repeatedly deployed to target maritime shipping and energy infrastructure. By forcing commercial vessels to reroute around volatile zones, these asymmetric attacks increase international shipping durations, escalate insurance premiums, and disrupt global supply chains. Consequently, the misuse of drone technology has expanded local conflicts into broad macroeconomic vulnerabilities. As the threat of drone misuse expands, sovereign nations face the critical task of upgrading their defense architectures. Modern national security requires robust counter-UAS or counter-drone systems alongside advanced border surveillance grids to protect territorial integrity. However, this defense requirement must operate strictly within the boundaries of international humanitarian law. The ethical core of modern military innovation centers on the automation of the lethal kill chain, as artificial intelligence integration allows software to automatically detect, track, and categorize human targets. The risks of removing human judgment increases. This creates a severe accountability vacuum. If an autonomous algorithm incorrectly identifies a civilian vehicle as a military threat, assigning legal and moral responsibility becomes highly complex. To maintain compliance with humanitarian principles, international defense frameworks emphasize the absolute necessity of keeping a human in the loop. This protocol ensures that while machines process data and handle navigation, the qualitative, moral decision to apply lethal force remains strictly under human authorization, preventing software errors from causing catastrophic civilian harm. Mitigating the future risks of uncrewed warfare requires immediate coordinated international policy. This includes updating global export control regimes to track dual-use commercial components, establishing clear international treaties restricting fully autonomous lethal weapons, and implementing mandatory legal reviews for all AI-driven defense software. Uncrewed warfare requires immediate coordinated international policy. This includes updating global export control regimes to track dual-use commercial components, establishing clear international treaties restricting fully autonomous lethal weapons, and implementing mandatory legal reviews for all AI-driven defense software. Ultimately, the rapid rise of drone technology forces us to examine a critical balance. Technological innovation is continuous, and the requirement for national security is absolute. However, if these tools are not permanently bound to strict ethical frameworks and global humanitarian principles, the systems designed to defend national sovereignty risk, undermining our collective global security. The future of modern defense relies not just on smarter engineering, but on stronger international responsibility.